A reading program for 4th grade students randomly selected 20 books from their recommended titles. The number of pages for each book is listed below. Assume the population is normally distributed. Construct and interpret a 95% confidence interval for the mean number of pages in all books from this program's recommended list. Again, let's write down our steps. Number 1, we'll need the mean, the standard deviation, and the size of the sample. And this time we aren't given a mean. So instead what we'll do is say equals average of the list. We'll call this x bar. The standard deviation will be STDEV dot S of the list. We'll call this S. The size of the sample is given to us here in that it says 20 books. But if we didn't know that, we could do equals count and again select the list. This will be our N. Our second order of business will be to use the confidence level to find alpha and then use alpha to find T critical. The alpha is always 1 minus the confidence, and then the T critical will use the special Excel formula T dot inverse, or INV, dot two-tailed, or 2T. Inside the parentheses, we'll enter alpha, comma, n minus 1. Once we've gathered up all that information, we can say the error is equal to T critical times S divide square root of n. After we find error, we can say the lower is the mean, or x bar, minus the error, and the upper is the mean, x bar, plus the error. Now that we have our steps written out, let's get started. In our first step, let's collect the mean, the standard deviation, and the sample size. We'll say equals average, parentheses, and select the entire list. The standard deviation, we'll say STDEV dot S, and again select the entire list. And for the size of the sample, we say equals count, and once again select the entire list. This gives us our first few pieces of information. After this, let's type our confidence, then our alpha, and then our T critical. Our confidence level, according to the question in line 3, we're given 0.95 or 95% confidence. The alpha will be equal to 1 minus the confidence. And the T critical will be T.INV.2T. Select the alpha, comma, the size minus 1. This gives us our T critical. Based on this, we can get error, and then the lower and the upper. Our formula for error in step 3 is T critical. Click on that, multiply by the standard deviation, S, divide by square root of the size, n. This gives us our error. We can say the lower bound is the mean minus the error. And the upper bound is the mean plus the error. And so we have our lower and upper. 149.028 and 193.472. What this means is that we can say with 95% confidence that the true mean is between these two numbers. Now, what could be slightly misleading about this problem is that we are told that it's normally distributed, but instead of using the norm, we are using the t-distribution. There are two reasons for that. First, the sample size that we used is only 20. That's less than the 30 we would need to use norm. Now, you could use norm if the size was greater than 30. However, also, in order to use norm, we must also know the population's standard deviation. The standard deviation that we have here is the sample standard deviation. However, that only tells us what the standard deviation is for these 20 samples. We actually don't know the rest of the population's standard deviation. Therefore, we still use T inverse two-tail. For most of the problems in this course, if you're ever working with averages, you'll generally use the t-distribution, because most of the time we'll either have a small sample size or we won't know the population standard deviation. Generally, number 2 will almost never be given to you. Now, if you take more advanced statistics classes, we do need to keep our eye open for that. So for those of you going on to Math 251, you may need to keep it in mind then. For the purposes of Math 152, it's not as important.